Today we're going to talk about healthcare digital twins. How do you track PPE and important equipment like ventilators using digital twins? What are digital twins? Digital twins are a bridge between the physical and the digital worlds. The state of the digital twin is maintained alongside of the physical state, typically using IoT. Complex relationships are modeled, strong query capabilities provide insights and analysis, and it is a robust simulation environment which can strengthen decision making. The digital twins market, worth $3.8 billion in 2019, is projected to reach $35.8 billion in value by 2025. Deloitte also considers digital twins to be one of the top emerging trends of 2020. In order to maintain the state of healthcare digital twins, we must first tag the medical devices with serialized GTIN numbers on a barcode or RFID chip. Next, the device tags are scanned through mobile or fixed scanners, and EPCIS events are generated. The EPCIS events are transmitted to the digital twin system. GS1 standards create a robust base for creating digital twins. There's 3 steps to using the G-Twin platform. First, you import the GS1 standards data, then you can view and manipulate the digital twin, and then you can view the dashboard. So we'll start with importing data. We were provided GTIN and GLN information in a sample data set, a CSV file. So you can choose your CSV files and import them. Upon completion, you're asked to use a specific EPCIS endpoint to stream the EPCIS event data stream. So I can just do that through Postman. I also had done it through the EPCIS workbench. Here's a typical looking event with, I believe there's 4 different GTINs in here. 1, 2, 3, 4 to 1, 2, 3, 7. Are the serial numbers. So if I send that to my endpoint locally here, I'll just get a success to show me that it worked. And now I've populated all the information that I need to create the digital twin. Let's just have a look here. The GTIN information from the spreadsheet will actually just be creating instances of the first GTIN. We also have GLNs. We'll go a little bit further within the GLNs and we'll look at the state they're in, the city that they're in, the site, the sub-site, and we'll look at all the different relationships between these different areas or these different GLNs. So this one's a little bit longer. And again, we'll take a look at what that looks like in a moment. And EPCIS data has also come through. So here's the 4 serialized GTINs that we sent through Postman. Now we can click the digital twin graph. I've already opened it up here. And this is actually an Azure Digital Twins Explorer view. So what we're seeing here is the data structure that Azure Digital Twins are built off of. It's a graph-based database. So we get rich information on the relationships and a rich query language. So you can see updating here is the properties when I make a selection within the graph view. So this is a site that is a manufacturing plant. It has some different sub-sites. This is the shipping area, this is the production area, and this is the receiving area. Each of these has some extended metadata like temperature, humidity, throughput, desired throughput. We can actually change those right here. Let's go ahead and make the receiving area 110 degrees and we can save that. Now with this representation, as I said before, we get a robust query language. Right now I'm just selecting all of the various digital twins, but if we wanted to do something like see what sites and sub-sites have temperatures above 70 degrees. Let's run that query. And we'll see that there are 3 different sub-sites which have temperatures above 100 degrees. Here's that receiving that we set to 110 degrees. So some other queries we can do is we can look at if the different G10s have been sanitized. This is important for medical equipment that may go through a sanitation process, and you want to ensure that it has been sanitized before it gets back to use. We can do simple queries like list all of the cities within our data set. We could, of course, list all of the states within our data set. We can search for items within a specific GLN. So these are all of the items that are within, I believe this was the production area. The dashboard gives a real-time view of an indoor map of the location. You can see each of the G10s on the map, as well as get information on their state. Their G10, whether or not they've been sanitized, whether or not they need maintenance, and their current utilization rate. Digital twins can future-proof the medical supply chain by adding visibility, optimizing deployment, increasing device reuse, and by ensuring the right devices are on hand in the right state.